Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening.
Waalaikumsalam
Waalaikumsalam.
warahmatullahi
Nurul.
wabarakatuh.
Waalaikumsalam.
So today we will continue our lesson with lesson 2, topic 6, periodicity. Okay, so what we will learn for this evening is first factors. We will discuss the factors affecting the periodicity. And then we will discuss the trends of atomic radii, electronegativity, and ionization energy across period and down a group. And then we will compare size of ion with its respective atom. And then I will teach you how to answer related question. Are you ready, class?
Yes,
Yes.
madam.
Yes,
Yes,
madam.
madam.
Yes.
Alright. So we go to the first objective, factors affecting the periodicity. We have two factors that will affect the periodicity. The first one is the shielding effect. The second one is the effective nuclear charge. So we will discuss one by one. Okay. So we go to the first one, shielding effect. So what is the shielding effect? Is the existence of inner electrons shield the attraction of the nucleus towards the outermost shell electron. The existence of inner shell electron that shield the attraction of the nucleus toward the outermost shell electron. So this shielding effect will reduce the attractive forces between nucleus and the outermost electron. So the difference of shielding effect between elements can be seen when you have element that is down a group, which is the element that has different number of shell. Okay, the shielding effect can be seen for the elements that has different number of shell. Okay, so we will use sodium as an example to illustrate what is exactly the shielding effect. Okay, so we know that number of proton for sodium is 11. So in the nucleus of sodium, there are positive 11 charge. So from the electronic configuration, we also know that in shell 1 we have 2 electron. In shell 2 we have 8 electron. Okay, this one shell 1, this one shell 2, and then shell 3 we have how many electron? 1.
One.
So the electron in 3s orbital here is said is known as outermost shell electron. The electron in shell 2 and shell 3 here we call as inner shell electron. Okay, so the outermost shell electron here does not feel full attraction towards the nucleus. It does not feel the full attraction. Okay, because the attraction is shielded by the electron in the inner shell. Do you understand? So that is what we call as shielding effect. So when you have more shell, means that you will have more inner electron. So means that your shielding effect will increase. Okay, so the shielding effect is affected by the number of shell because when you have more shell means that you have more inner electrons. So what happen after that? Your shielding effect will be increased. Any question, class?
No, madam.
No, madam.
Okay. Understand about the shielding effect?
Yeah.
Yes.
Okay, good. So, the as a conclusion, when we have more shell, like I said earlier, we will have more inner electron, so it will cause the shielding effect to be increased. So when shielding effect is increased, therefore it will affect the nucleus attraction towards outermost electron. Means that it will weaker the nucleus attraction towards outermost electrons. Okay, so the conclusion here, when shielding effect is high, the nucleus attraction will be low. So we go to the second one, which is effective nuclear charge. Okay, so what if effective nuclear charge is the net charge? Okay, net charge felt by the outermost electrons towards the nucleus. Sorry, the spelling of nucleus is wrong. Should be okay. So, since that the effective nuclear charge is the net charge, so it always has positive value. So to calculate the positive value, we need to use this formula. Okay, what is ZEFF here? This one is the symbol for effective nuclear charge. Okay, so effective nuclear charge is equals to Z. Z is the number of proton of your element minus number of inner electron. So the difference of effective nuclear charge. Okay, so the difference of effective nuclear charge can be seen for element that is a closing period. Means that that element will have same period but different group. Okay, the element have same period but different group. So the value of Z here, the value of Z indicates how strong your attraction between nucleus and the outermost electron. So we will use sodium as an example. Okay. So how to calculate the Z for for sodium? Okay, so that we know the number of proton for sodium is 11 minus its inner electron is 10. So your Z for sodium is positive 1. So the value here indicate how strong the attractive force between the nucleus and the outermost electron of the elements. Okay, so if you have higher Z means that you have stronger nucleus attraction. Cause and effect of the effective nuclear charge. So the effective nuclear charge is depends on the number of proton. When you have more proton number or more number of proton, it will cause the effective nuclear charge to be increased. So when effective nuclear charge is increased, it will give you the stronger nucleus attraction. This one is the effect of the higher effective nuclear charge. So means that if you have a Zephyr, so means that you have stronger nucleus attraction.